There's a name buried in history that you've probably never heard, yet you use his work every single day. Every time you check the time, split a bill, or unlock your phone with a passcode, you're using systems he invented over 1,000 years ago. The man who gave us algebra, who revolutionized mathematics, who changed how humans think about numbers, lived in a world most of us can barely imagine. His story begins not in triumph, but in chaos. The year is 780, roughly. We don't know the exact date. Record-keeping in Central Asia wasn't what it would become, and the man himself never wrote an autobiography. What we know comes from fragments, from the books he wrote decades later, from the scholars who studied under him, from the empire that rose and fell around his work. His name was Muhammad ibn Musa al-Khwarizmi. The last part, al-Khwarizmi, tells us where he came from. Khwarizm, a region south of the Aral Sea, in what is now Uzbekistan. A place of desert and oasis, of ancient trade routes and older civilizations. But Khwarizmi wasn't born into a world of libraries and learned debate. He was born into upheaval. The Abbasid revolution had just convulsed the Islamic world, overthrowing the Umayyad dynasty in a wave of violence that reshaped everything, from Spain to the borders of India. The new caliphs moved the capital from Damascus to a city that didn't even exist yet, Baghdad. They would build it from nothing on the banks of the Tigris River, and it would become the greatest city on earth. Khwarizmi would end up there. But first he had to survive childhood in a world being torn apart and rebuilt simultaneously. Khwarizm itself was a crossroads. Persian culture dominated, but the region had been conquered by Arabs spreading Islam eastward. Greek learning filtered in from the west. Indian mathematics arrived along trade routes from the south. Chinese innovations travelled the Silk Road from the east. If you wanted to understand the world in 780, Khwarizm wasn't a bad place to be born, assuming you lived long enough to learn anything. We know almost nothing about Khwarizmi's childhood. No letters survive, no personal accounts. Medieval biographers cared about a man's work, not his feelings or his early years. But we can reconstruct the world he inhabited. His father, Musa, was likely a minor official or perhaps a merchant. The family wasn't wealthy, but they weren't destitute either. Somewhere in the middle, educated enough to value learning, connected enough to know what was happening in the wider world. The boy would have learned to read and write Arabic, the language of religion and administration. He would have memorized portions of the Quran, standard education for any Muslim child. Mathematics would have come later, probably from a local teacher who understood Persian and Indian calculation methods. The Arabic numeral system, which we still use today, was actually Indian in origin. It had been slowly spreading west, and Khwarizm was exactly the kind of place where different number systems collided and merged. Something happened in Khwarizmi's teenage years that changed everything. His family moved to Baghdad. Why, we don't know. Perhaps his father got a position in the new capital. Perhaps they were fleeing some local conflict. Perhaps they simply saw opportunity in the city that the Abbasid caliphs were building into the intellectual centre of the world. The journey would have taken weeks, following trade routes west and then south, crossing deserts and rivers, passing through cities that had stood for thousands of years. Baghdad, in 800, was barely a generation old, but it was already extraordinary. The Caliph Harun al-Rashid, the one who shows up in the Arabian Nights stories, was at the height of his power. He'd built a palace complex that covered acres. The city itself was designed as a perfect circle, walls within walls, with the Caliph's residence at the exact centre. 500,000 people lived there, maybe more. Scholars, merchants, soldiers, craftsmen, slaves, administrators, every language you could imagine echoed through the markets. And the Caliph was obsessed with knowledge, not just Islamic knowledge, though that mattered too. He wanted everything. Greek philosophy, Persian astronomy, Indian mathematics, Chinese medicine. He sent agents across the known world with bags of gold, buying manuscripts. He established a translation bureau, paying scholars to render ancient texts into Arabic. The House of Wisdom, as it came to be called, was less a single building than a movement. Baghdad was becoming a library, a university, a laboratory. Khwarizmi was in his 20s when he entered this world. Imagine the shock of it, coming from a provincial backwater to the greatest city on earth, where the Caliph himself funded scholars to pursue knowledge for its own sake, where you could find books that existed nowhere else, where the smartest people from 3 continents gathered to argue about mathematics and astronomy and philosophy. He got a job. How? Who recommended him? We don't know, but by 820, Khwarizmi was working at the House of Wisdom, attached to the Caliph's court, with access to resources that would have seemed impossible a decade earlier. He was a junior scholar, probably, not yet famous, not yet important, just another young man trying to make sense of the contradictory mathematical traditions that had accumulated in Baghdad's libraries. The Greeks had geometry, elegant, rigorous, based on proof and logical deduction. Euclid's Elements was already ancient by Khwarizmi's time, and it was still the foundation of mathematical education. But Greek mathematics was visual, spatial. It struggled with certain kinds of problems, especially anything involving unknowns or systematic calculation. The Indians had arithmetic. They developed the decimal place value system, the concept of zero as a number, efficient algorithms for multiplication and division. Their methods were practical, powerful, but less interested in proof than in getting the right answer quickly. The Babylonians, or rather their intellectual descendants, in Persia, had something else: techniques for solving specific types of problems, recipes almost. If you have this situation, do these steps, get this answer. It worked, but no one really understood why. Khwarizmi looked at this mess and saw an opportunity. What if you could create a unified system? What if you could take the rigor of Greek geometry, the efficiency of Indian arithmetic, and the problem-solving techniques of the Persians, and forge them into something new, something systematic, teachable, universally applicable? That question would consume the next decade of his life. But before he could answer it, he needed to prove himself. The Caliph and his administrators had practical problems that needed solving, problems of inheritance, of taxation, of land surveying, of commercial law. Islamic inheritance law was particularly complex. When a man died, his property had to be divided among his wives, his children, his parents, according to precise Quranic formulas. If the family included half-siblings, multiple wives, adopted children, the calculations became nightmarish. Merchants needed to split profits fairly among investors who had contributed different amounts. Tax collectors needed to calculate revenues from irregularly shaped fields. Engineers needed to design irrigation systems that would deliver water to specific locations. None of these were abstract problems. These were the daily headaches of running an empire that stretched from Spain to India. Khwarizmi started working on these practical questions, and in doing so, he began to see patterns. The inheritance problems, the commercial partnerships, the geometric calculations, they all reduced to the same underlying structure. You had known quantities and unknown quantities. You had relationships between them. If you could express those relationships symbolically, manipulate them according to consistent rules, you could solve whole categories of problems at once. This was the seed of algebra. Not the word yet, that would come later, but the idea, the revolutionary idea that you could treat unknowns as if they were knowns, manipulate them, isolate them, solve for them. It sounds obvious now. We learn it in middle school, but in 820 it was genuinely new. The Greeks had hints of it. The Indians had pieces. The Babylonians had specific techniques. No one had put it together into a coherent system. Khwarizmi worked in obscurity for years. The sources don't tell us what he was thinking, what failures he encountered, what moments of insight kept him going. We only know the result. Sometime around 830 he finished a book, a short book by modern standards, fewer than 100 pages in translation, but those pages would change the world. The title was Kitab al-Mukhtasar fi Hisab al-Jabr wal-Muqabala, the compendious book on calculation by completion and balancing. That word in the middle, al-Jabr, meant restoration or completion. It referred to a specific technique, moving terms from one side of an equation to another to simplify it. Later, Europeans would transliterate that word into their own languages. Al-Jabr became algebra. The book opened with a dedication to the Caliph, Al-Ma'mun, Harun al-Rashid's son, who had succeeded his father and continued the patronage of learning. Khwarizmi explained his purpose. He wanted to create something useful for ordinary people dealing with everyday problems. Inheritance, legacies, lawsuits, trade, land measurement, nothing abstract, nothing philosophical, just practical tools that anyone could learn and apply. Then he did something radical. He classified problems into types, 6 types to be exact. Each type had a systematic solution method. Learn the method, apply it to your specific situation, get your answer. It was algorithmic thinking, step-by-step procedures that worked every time if you followed them correctly. And yes, the word algorithm comes from Khwarizmi's name. Europeans reading Latin translations of his work centuries later thought algorisma was the name of a mathematical technique, not realizing it was a Latinized version of al-Khwarizmi. The 6 types were equations we'd now write as linear and quadratic. Things like squares equal roots, or squares and roots equal numbers. He showed how to solve each type through al-Jabr, moving terms around, and al-Muqabala, reducing and balancing. He gave geometric proofs for why the methods worked, satisfying the Greek demand for logical rigor. And he included dozens of worked examples, showing exactly how to apply the techniques to real problems. Was it perfect? No. He didn't have symbolic notation as we know it. Everything was written out in words. A square and 10 roots equal 39, instead of x squared plus 10x equals 39. He didn't recognize negative numbers as legitimate solutions. He didn't have a general theory covering all possible cases, but what he created was teachable, usable, and revolutionary. The book spread, slowly at first, then faster. Other scholars at the House of Wisdom read it, recognized its value, began teaching it to their students. Copies were made, carried along trade routes to other cities. Within a generation, Khwarizmi's algebra was being taught across the Islamic world. Students in Cordoba and Cairo were learning the same techniques as students in Samarkand and Baghdad, but Khwarizmi wasn't finished. The algebra book had solved one set of problems, but there were others. The Indian numeral system, with its place value notation and zero, was clearly superior to the systems used in the West. But most people in the Islamic world didn't know how to use it. Merchants still calculated with finger reckoning or counting boards. Scholars still use clumsy Greek or Roman numerals for written calculations. Khwarizmi saw another opportunity. If he could write a clear, practical guide to the Indian system, he could revolutionize not just advanced mathematics, but everyday arithmetic. And that's exactly what he set out to do. Around 825, Khwarizmi completed his second masterwork. The title, translated into English, reads Book of Indian Computation, though later Latin versions would call it Algoritmi de Numero Indorum. This book would do for arithmetic what the algebra text had done for equation solving. It would take knowledge locked away in specialized circles and make it accessible to anyone willing to learn. The timing was perfect. Baghdad's markets were expanding. Trade routes stretched from Spain to China. Merchants needed to calculate quickly, accurately, or reliably. The old methods were breaking down under the volume of commerce. Roman numerals could express any number, sure, but try multiplying m, c, m, l, x, 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 I, v by d, c, c, x, l, v, I in your head. Try doing it on paper without making errors. Try teaching it to a clerk who needs to process hundreds of transactions per day. The Indian system was different. 10 symbols, 0 through 9, position mattered. The same digit meant different things depending on where it sat. A 3 in the ones place meant 3, in the tens place, 30, in the hundreds place, 300. Simple, elegant, powerful beyond measure, but it required a mental shift. You had to think differently about numbers. You had to accept that emptiness, represented by 0, was itself a number. You had to trust that moving a digit one place to the left automatically multiplied it by 10. These weren't difficult concepts, but they were unfamiliar. Someone had to explain them clearly, step by step, with examples that made sense. Khwarizmi started with the basics: how to write numbers using the 9 Indian symbols plus the 0, how to understand place value, how to recognize that 305 and 350 and 503 were completely different numbers despite using the same 3 digits. He worked through addition, showing how to line up the columns, add digit by digit, carry when necessary. Then subtraction with borrowing, then multiplication, breaking it down into steps that became automatic with practice. Division was trickier. The Indian method was algorithmic, mechanical, but it took time to master. Khwarizmi walked readers through it patiently, showing the process with multiple examples until the pattern became clear. He included techniques for checking your work, for catching errors before they compounded. What made the book revolutionary wasn't just the content, it was the approach. Khwarizmi wasn't writing for scholars who already understood mathematics. He was writing for scribes, accountants, tax collectors, merchants, people who needed practical skills, not theoretical knowledge. Every explanation was concrete. Every example was something you might actually calculate in real life. The book spread even faster than the algebra text. Why? Because the benefits were immediate and obvious. A merchant who learned the Indian system could calculate in minutes what previously took hours. An accountant could process more transactions with fewer errors. A surveyor could measure land more accurately. The advantages weren't subtle or philosophical. They were right there in the counting house, in the tax office, in the marketplace. European scholars would eventually encounter Latin translations of this work in the 12th century. They called the new numbers Arabic numerals because they learned them from Arabic texts, not realizing the system had come from India. The name stuck. We still call them Arabic numerals today, even though Khwarizmi himself always credited the Indians. But here's what's fascinating. Khwarizmi didn't just transmit knowledge, he adapted it. The Indian mathematicians who developed these techniques were working within their own cultural and intellectual context. They had their own notation, their own ways of explaining things, their own applications in mind. Khwarizmi took that raw material and reshaped it for a different audience, a different set of needs, a different world. He simplified where Indian texts were complex. He systematized where they were discursive. He focused relentlessly on practical application, where they sometimes wandered into philosophy. This wasn't plagiarism. This was translation in the deepest sense, not just converting words from one language to another, but converting ideas from one intellectual universe to another. And he was doing this at the House of Wisdom, surrounded by other scholars doing similar work. Someone was translating Greek astronomy, someone else was working on Persian history, someone was studying Indian medicine, someone was compiling Arabic poetry. The place was a hive of intellectual activity, and Khwarizmi was right in the center of it. What drove him? We can only speculate, but the books themselves suggest an answer. He wasn't interested in mathematics for its own sake. He never wrote purely theoretical treatises. Everything he produced was aimed at solving real problems, at giving people tools they could actually use. There's a kind of democratic impulse in that, a belief that knowledge shouldn't be hoarded by an elite, but shared as widely as possible. The Caliph certainly appreciated it. Al-Mamun continued funding the House of Wisdom. continued supporting scholars like Khwarizmi. But the Caliph's interests went beyond practical computation. He wanted prestige. He wanted his court to be seen as the intellectual centre of the world. He wanted to surpass the ancient Greeks, to prove that Islamic civilization could achieve things even Athens and Alexandria had not. Khwarizmi's next project would serve that ambition perfectly. He turned his attention to astronomy and geography, fields where the Greeks had excelled but where newer observations and better mathematical tools could push knowledge forward. The challenge was enormous. Greek astronomy, particularly Ptolemy's work, was sophisticated and detailed. To improve on it, you needed better instruments, more observations, and mathematical techniques the Greeks hadn't possessed. Khwarizmi had access to all three. The House of Wisdom had astronomical instruments, some inherited from Persian tradition, some newly built. Observatories in Baghdad and Damascus were collecting data, and Khwarizmi himself had just written the book on algebraic methods that could be applied to astronomical calculations. He produced astronomical tables, updating and correcting Ptolemy's work. He calculated the positions of planets with greater accuracy. He worked out methods for determining the times of prayer, crucial for Islamic religious practice, which required knowing the position of the sun at different times of year in different locations. This wasn't abstract stargazing. It was applied mathematics serving a religious need. Then came the geography. Khwarizmi wrote The Image of the Earth, a comprehensive description of the known world. He listed cities, provinces, seas, rivers, mountains. He gave coordinates, latitudes, and longitudes for hundreds of locations. He corrected errors in earlier Greek maps. He incorporated information from Arabic travelers and traders who had been places Ptolemy never knew existed. The book was massive, detailed, systematic. It represented the cutting edge of geographical knowledge in the 9th century. And like everything Khwarizmi wrote, it was practical. These weren't just academic exercises. Merchants used the geographical data for planning trade routes. Pilgrims used it for journeys to Mecca. Military commanders used it for campaigns. The knowledge had immediate application. What's remarkable is how much one person accomplished. Algebra, arithmetic, astronomy, geography. Each of these would have been a significant career achievement on its own. Khwarizmi produced groundbreaking work in all of them, and he did it over the course of maybe 20 years, from roughly 820 to 840. How? Part of it was surely genius, raw intellectual horsepower. Part of it was the environment. Working at the House of Wisdom meant access to resources, to other scholars, to patronage that freed him from worrying about where his next meal was coming from. Part of it was timing. He lived at exactly the moment when different streams of knowledge, Greek, Indian, Persian, Arabic, were flowing together in Baghdad. He could see connections others missed because he was standing at the confluence. But part of it was also method. Everything Khwarizmi wrote shows the same approach. Break complex problems into simpler parts. Find systematic procedures that work reliably. Explain clearly, with examples. Test your methods against real-world needs. This wasn't just how he did mathematics. This was how he thought about everything. The legacy started accumulating even during his lifetime. Students were studying his books, learning his methods, applying them to new problems. The algebra text became a standard reference. The arithmetic book transformed how calculations were done across the Islamic world. The astronomical tables were copied and used for generations. The geography shaped how educated people understood the world's layout. But the real explosion came later, when European scholars discovered his work. In the 12th century, translators in Spain and Sicily began rendering Arabic scientific texts into Latin. Khwarizmi's books were high on the list. Robert of Chester translated the algebra book in 1145. Gerard of Cremona translated the astronomical tables. The arithmetic book circulated in multiple Latin versions. European mathematicians read these texts and recognized immediately that they were encountering something new. The algebraic methods were more powerful than anything in the classical Greek tradition. The Indian numerals were vastly superior to Roman numerals for calculation. Within a century, European mathematics was being revolutionized by techniques that had come from Baghdad. They didn't always understand what they were reading. The translators sometimes mangled the mathematics. The cultural context was lost. The careful explanations got compressed or confused. But the core ideas came through, and those ideas were explosive. You could solve equations systematically. You could calculate with unprecedented efficiency. You could describe the heavens with greater accuracy. Universities started teaching algebra. Merchants started using Arabic numerals. Astronomers started using Khwarizmi's tables. And the name Khwarizmi became algorithmus, became algorithm. The man became the method. His identity merged with his techniques, until European scholars, using algorithmic procedures, didn't even realize they were named after a person who had lived 3 centuries earlier in a city most of them had never seen. Was Khwarizmi aware he was creating something that would last? Probably not. He was solving problems, writing books, doing his job at the House of Wisdom. The idea that people 1,000 years in the future would still be using techniques he developed, that his name would be embedded in the vocabulary of mathematics and computer science, that school children across the world would be learning methods he systematized, all of that would have seemed absurd. But that's exactly what happened. The algorithms we use every time we multiply numbers, the algebraic equations we solve in school, the systematic problem-solving approaches that underlie modern computing, they all trace back to this one scholar working in 9th century Baghdad. He didn't invent mathematics, he didn't invent algebra, but he shaped these fields in ways that proved permanent, and he did it by focusing not on theory for its own sake, but on practical application. Not on impressing other scholars, but on helping ordinary people solve real problems. That choice, that orientation toward the useful rather than the abstract, made his work accessible, teachable, transmissible across cultures and centuries. By the time Khwarizmi died, probably sometime in the 800s and 50s, the House of Wisdom was at its peak. Scholars were translating, writing, debating, discovering. The library held tens of thousands of manuscripts. The observatory was producing new astronomical data. The whole enterprise seemed permanent, unshakable. It wouldn't last. Political changes were coming. The Abbasid Caliphate was beginning the long decline that would eventually end with Mongol invasion and the destruction of Baghdad. The House of Wisdom itself would be sacked in 1258, its books thrown into the Tigris until, legend says, the river ran black with ink. But by then, Khwarizmi's work had already escaped. Copies existed in libraries across the Islamic world. Translations were circulating in Europe. The knowledge had been set loose, and no amount of political upheaval could put it back in the bottle. The algorithms survived, but what about the man himself? What do we actually know about Muhammad ibn Musa al-Khwarizmi beyond his books? Almost nothing. We don't know when he was born. Sometime around 780, maybe earlier, maybe later. We don't know what he looked like. No portraits exist. We don't know if he was married, had children, or what his daily life was like outside the House of Wisdom. We have his books and a handful of references from other scholars. That's it. This absence is frustrating. Here's someone whose work shaped human civilization, and we can't even say what year he was born. But the absence also tells us something important about how knowledge worked in medieval Baghdad. Individual genius mattered less than institutional support. The House of Wisdom wasn't built around personalities, it was built around projects, the translation of Greek texts into Arabic, the compilation of astronomical tables, the systematization of mathematical methods. Scholars came, did their work, and left. What mattered was the work. Khwarizmi fit perfectly into this system. He wasn't trying to build a personal legacy, he was trying to solve problems. The Caliph needed better astronomical predictions. Khwarizmi would produce tables. Merchants needed calculation methods. He'd write a manual. Administrators needed to divide inheritances according to Islamic law. He'd systematize the algebra required. This practical orientation shows up everywhere in his writing. His books aren't philosophical treatises, they're instruction manuals. Step 1, Step 2, Step 3. Here's the problem. Here's how you solve it. Next problem. The tone is patient, methodical, almost bureaucratic. Consider how he explains the fundamental operations of algebra. He doesn't start with abstract principles. He starts with 6 basic equation types that cover every linear and quadratic equation you might encounter. Each type gets worked examples. Each example shows exactly what to do in order, with no steps skipped. It's teaching designed for transmission. Someone reading Khwarizmi's algebra book could learn the methods and then teach someone else. That person could teach another. The knowledge could spread without requiring access to the original author or some mystical insight. Just follow the steps. This was radical. Greek mathematics, brilliant as it was, often relied on a geometric intuition that was hard to communicate. You either saw why something was true, or you didn't. Khwarizmi's approach was different. You didn't need to see anything. You just needed to follow the procedure. And procedures can be taught to anyone. The social implications were enormous. In a world where mathematical knowledge was restricted to a small educated elite, Khwarizmi was democratizing access. His methods could be learned by merchants, by administrators, by anyone literate enough to read Arabic. Mathematics was becoming a tool rather than a mystery. This wasn't accidental. The Abbasid Caliphate had practical reasons to want mathematical knowledge distributed widely. Tax collection required calculation. Inheritance law required division. Architecture required geometry. Commerce required accounting. A functional empire needed functionaries who could handle numbers, and Khwarizmi was providing the textbooks. But there's a tension here worth examining. Khwarizmi was working within an imperial system, supported by a caliph who wanted useful knowledge for running an empire. Does that make him merely a tool of power? A court mathematician serving political masters? Not quite. The thing about writing a good textbook is that once it exists, you can't control who reads it. Khwarizmi wrote for the Abbasid administration, but his books ended up being read by everyone. Merchants used his methods to track their profits. Religious scholars used his astronomy to calculate prayer times. Students used his algebra to solve problems Khwarizmi never imagined. Knowledge, once released, goes where it wants to go. This becomes especially clear when we look at how Khwarizmi's work spread beyond the Islamic world. The Latin translations that appeared in the 12th century weren't commissioned by any caliph. They were the work of individual translators, mostly working in Spain, who recognized that these Arabic texts contained mathematics Europe desperately needed. Gerard of Cremona, one of the most prolific translators, rendered Khwarizmi's astronomical tables into Latin around 1140. Robert of Chester translated the algebra book in 1145. These weren't state projects. They were intellectual entrepreneurs recognizing valuable knowledge and making it accessible to a new audience. The translations were imperfect. Medieval Latin lacked good mathematical vocabulary. Concepts that were clear in Arabic became muddy in translation. But the core methods came through, and that was enough. European mathematics, which had been stagnant for centuries, suddenly had new tools. Universities started teaching algebra in the 13th century, not because anyone ordered them to, but because students wanted to learn it. The techniques were too useful to ignore. By the 14th century, you couldn't be considered an educated person in Europe without knowing at least basic algebra. And all of this traced back to books written in Baghdad 2 centuries earlier by a scholar trying to help merchants divide inheritances and calculate trade profits. There's something almost miraculous about this transmission. Khwarizmi wrote in Arabic for an Islamic audience under the patronage of an Abbasid caliph. His work was read in Latin by Christian Europeans under completely different political and religious systems. The content survived the transition. The mathematics didn't care about the cultural context. This suggests something profound about knowledge itself. Mathematical truth isn't bound by the circumstances of its discovery. 2 + 2 = 4 in Baghdad and Paris and Beijing. The quadratic formula works regardless of who's using it or why. Once a method is discovered and clearly explained, it becomes available to anyone with the patience to learn it. Khwarizmi understood this. His writing shows no concern with who might eventually read his books, or what they might do with the knowledge. He's focused entirely on clarity, on making the methods as transparent and learnable as possible. Trust the mathematics, teach it well, and let it go where it needs to go. This attitude stands in sharp contrast to earlier mathematical traditions where knowledge was often guarded. The Pythagoreans had secrets they revealed only to initiates. Some Greek mathematicians deliberately made their proofs obscure to prevent others from stealing their discoveries. Khwarizmi did the opposite. He made everything as clear as possible. Why? Partly because he was writing instructional texts rather than research papers, but also perhaps because he was working in an environment where knowledge sharing was valued. The House of Wisdom was fundamentally a collaborative enterprise, scholars from different backgrounds working together, building on each other's discoveries, translating and synthesizing and extending. You can't hoard knowledge in that environment. The whole point is collective advancement. This collaborative spirit shows up in how Khwarizmi credits his sources. He acknowledges Indian methods for arithmetic. He references Greek astronomical texts. He builds on earlier Arabic scholars. There's no pretense that he's inventing everything from scratch. He's standing on shoulders, and he knows it. Modern scholars sometimes criticize him for this. They point out that much of his algebra was known to earlier mathematicians. His astronomical tables borrowed heavily from Indian and Persian sources. He was more synthesizer than innovator, but this criticism misses the point. Synthesis is innovation. Taking scattered knowledge from multiple traditions, organizing it systematically, presenting it clearly, making it teachable. This is enormously valuable work. It's arguably more valuable than discovering something brilliant that nobody else can understand or use. Khwarizmi's genius wasn't in being the first to think of algebraic methods. It was in being the first to present them in a way that could be widely adopted. He transformed algebra from a collection of scattered techniques into a systematic discipline with standard procedures and clear applications. That's why his name stuck to the subject. That's why algebra comes from his book title rather than from some earlier mathematician who might have used similar methods but never wrote them down systematically. The written word matters. The textbook matters. The clear explanation matters. And Khwarizmi was a master of all three. But let's return to that original question. What do we actually know about him as a person? We know he worked at the House of Wisdom. We know he wrote multiple books on different subjects. We know other scholars referenced his work with respect. Beyond that, we're guessing. Some scholars think he was born in Khwarizm, a region in Central Asia, based on his name. Others argue he might have been born in Baghdad, and his name refers to his family's ancestral home. We don't know which is correct. We don't know if he had students. We don't know if he trained successors or if his work was simply absorbed into the general pool of mathematical knowledge at the House of Wisdom. We don't know how long he lived or where he died. The historical record is silent on all these personal details. What survives is the work, and the work is enough. This raises an interesting philosophical question. Does it matter who Khwarizmi was as a person? We have his books, we can study his methods, we can trace his influence. Do we need to know anything else? Part of me wants to say no. The mathematics speaks for itself. Khwarizmi's personal biography is interesting but ultimately irrelevant to understanding why his work matters. But another part recognizes that we lose something important when we reduce historical figures to their accomplishments. Khwarizmi was a human being. He had thoughts, feelings, relationships, daily routines. He existed in a specific time and place, navigated specific social structures, made specific choices about how to spend his limited time on Earth. All of that shaped his work in ways we can't fully recover. The choice to write practical textbooks rather than theoretical treatises. The decision to focus on methods that could be learned by non-specialists. The careful organisation and clear prose style. These weren't inevitable. They reflect someone's personality, values, circumstances. We just don't know whose. The frustration of historical research is that sometimes the most important people leave the smallest traces. Khwarizmi changed mathematics. His name became a fundamental term in computer science. His books were studied for centuries, and yet he remains almost invisible as an individual. Compare this to Al-Ma'mun, the caliph who founded the House of Wisdom. We know far more about Al-Ma'mun's personal life, his political struggles, his religious views, his military campaigns. Historians wrote about him extensively because he had political power. Khwarizmi had no political power. He was a scholar doing technical work. Nobody wrote his biography. Nobody recorded his personal opinions. He mattered to mathematics but not to politics, and medieval historians cared about politics. So we're left with books and influence. The work survives, the person fades. This pattern repeats throughout history. The people who change how we think, who develop new methods and tools, often leave minimal personal traces. Meanwhile, people who wielded power but contributed little intellectually get extensive documentation. It's backwards, but it's how historical memory works. Still, we can extract some things about Khwarizmi from his books. The patience required to write clear instructional texts suggests someone methodical and careful. The range of subjects he addressed, astronomy, geography, arithmetic, algebra, suggests broad interests and intellectual curiosity. The practical orientation of his work suggests someone concerned with real-world applications rather than abstract theory. These are inferences, not facts, but they're all we have. What we can say with certainty is this: Khwarizmi lived in Baghdad during the 9th century. He worked at the House of Wisdom under the patronage of Caliph al-Ma'mun. He wrote books on mathematics and astronomy that profoundly influenced both Islamic and European intellectual traditions. His name became permanently attached to systematic calculation methods, and somewhere in all that institutional work and intellectual influence, there was a person, someone who woke up each morning, walked to the House of Wisdom, sat down with pen and paper, and worked out how to explain complex ideas simply. Someone who cared enough about teaching to write clearly. Someone who thought the effort worthwhile, even though nobody would remember his name. And perhaps that's the real lesson here, not just what Khwarizmi accomplished, but what he represents. A reminder that some of the most transformative work in human history gets done by people we'll never fully know. People who cared more about solving problems than being remembered. People whose legacy is embedded in how we think, rather than in monuments or biographies. The algorithm doesn't care who invented it. The algebra textbook doesn't need its author's personality to be useful. The mathematical methods work regardless of whether we know anything about the mathematician, but we should care anyway. Not because it changes the mathematics, but because it changes how we understand intellectual progress. The Romantic myth says, great discoveries come from lone geniuses working in isolation, driven by personal brilliance. The reality is messier. Great discoveries come from people embedded in institutions, supported by patrons, building on previous work, responding to specific practical needs. Khwarizmi wasn't a lone genius. He was part of a system. The Abbasid Caliphate created institutions that supported scholarship. The House of Wisdom brought together people working on different problems. Translation projects made Greek, Persian, and Indian knowledge available. Patrons funded work that had no immediate political or economic payoff. Take away any of those elements and Khwarizmi's work either doesn't happen or doesn't spread. The individual matters, but so does everything surrounding the individual. This becomes important when we think about how to encourage innovation today. We tend to focus on finding brilliant people and getting out of their way, but maybe we should focus more on building institutions, creating collaborative environments, making knowledge accessible, supporting work whose value isn't immediately obvious. Khwarizmi's biography is mostly lost, but the structure that enabled him isn't. We can study how the House of Wisdom functioned, how the translation movement worked, how patronage networks operated. We can learn from the institutional framework, even if the individual remains mysterious. Which brings us back to the books. Not as impersonal technical documents, but as artifacts of a specific moment. Someone in 9th century Baghdad decided these problems were worth solving. Someone thought merchants needed better arithmetic methods. Someone believed students could learn algebra if it was explained clearly enough. Those decisions reflect a worldview, a belief that knowledge should be accessible, that practical problems deserve serious attention, that clear explanation is valuable. You can glimpse a person's values even when you can't reconstruct their life. The Al-Kitab al-Mukhtasar shows us someone who believed mathematics should serve people, not just impress other mathematicians. The systematic approach suggests someone who thought carefully about pedagogy, about how learners actually process information. The choice to write in Arabic rather than Greek or Persian suggests someone thinking about their immediate audience, rather than eternal prestige. These aren't definitive personality assessments. They're hints, shadows of intention, but they're better than nothing. What would Khwarizmi make of his legacy? Would he be surprised that his name became attached to all systematic calculation? Would he be pleased that his algebra book influenced mathematics for centuries? Would he care that we remember his work but not his life? Impossible questions. We can't know how he thought about his own significance, but we can make some educated guesses based on how he worked. Someone who writes practical textbooks probably isn't primarily concerned with immortal fame. Someone who focuses on clear explanation probably cares more about being useful than being celebrated. Someone who develops methods for merchants and administrators probably thinks service matters more than glory. This would make Khwarizmi different from many historical figures who clearly courted recognition. He wasn't building monuments. He wasn't writing grand philosophical treatises. He was solving specific problems in ways that specific people could use. And somehow, by focusing on the practical and immediate, he created something that lasted far longer than most monuments. The textbook outlived the empire. The methods outlasted the institutions. The name survived even as the person faded. There's an irony there. The people most concerned with being remembered often aren't. The people focused on doing useful work sometimes are. Not always. History forgets most people regardless, but often enough to notice the pattern. Khwarizmi built tools. Tools are judged by whether they work, not by who built them. A good hammer doesn't need its maker's biography stamped on the handle. It just needs to drive nails effectively. Algebra is a tool. Algorithms are tools. They work or they don't. The personality of their creator is irrelevant to their function. But tools still come from somewhere. They don't emerge spontaneously from the void. Someone has to recognize the need, develop the solution, test it, refine it, explain it to others. That process involves human judgment, human choices, human effort. We can acknowledge that without needing complete biographical details. We can recognize that Khwarizmi made specific choices that shaped mathematics without needing to know what he ate for breakfast or how he felt about his colleagues. The middle path between romantic genius myth and impersonal institutional history is to see people as embedded agents, neither lone heroes nor interchangeable cogs, but individuals operating within structures and making choices that matter while constrained by circumstances beyond their control. Khwarizmi couldn't have done his work without the House of Wisdom, but the House of Wisdom needed people like Khwarizmi to fulfill its mission. The institution and the individual were mutually constitutive. This perspective helps explain why we know so little about Khwarizmi personally, but can still understand his significance. The work itself contains traces of the choices he made, the values he held, the problems he considered worth solving. We don't need a diary to see that he valued clarity over complexity, practice over theory, accessibility over exclusivity. These values show up in how he wrote. The step-by-step approach, the concrete examples, the systematic organization. You can't write like that without believing that clear communication matters. Compare this to some mathematical texts from the same period that were deliberately obscure, written to impress rather than to teach. Those authors had different values. They wanted to demonstrate their cleverness, to preserve secrets within an elite circle, to make mathematics seem mysterious and difficult. Khwarizmi did the opposite. He demystified mathematics. He showed that anyone could learn these methods if they were explained properly. That choice has ethical implications. Making knowledge accessible is a political act, even if it doesn't seem political at the time. It redistributes intellectual power. It challenges hierarchies. It suggests that expertise should serve broader social needs rather than just reinforcing elite status. Did Khwarizmi think about it in those terms? Probably not explicitly, but his choices had those effects regardless of his conscious intentions. This is another reason why biographical details matter less than we might think. People's explicit beliefs about what they're doing often differ from the actual effects of their work. Khwarizmi might have thought he was just writing a textbook, but he was also participating in a broader democratization of knowledge. The House of Wisdom itself represented this democratization. By translating texts from multiple languages and traditions, it made knowledge available that had previously been locked within specific cultural or linguistic communities. Khwarizmi's work extended that project into new domains. Algebra wasn't invented in Baghdad. The underlying ideas came from earlier sources, but Khwarizmi systematized them, explained them clearly, and presented them in a way that allowed transmission across cultural boundaries. That's a different kind of innovation than pure discovery. It's also a kind of innovation that often gets overlooked. We celebrate people who discover new things more than people who explain existing things well. But explanation is crucial. A discovery that can't be communicated or taught has limited impact. Khwarizmi's genius was pedagogical as much as mathematical. He understood not just how to solve problems, but how to teach problem solving. That's a rare combination. Think about the algebra book's structure. It doesn't start with abstract theory. It starts with practical problems that anyone can understand. Dividing inheritances, calculating areas, solving commercial disputes. Only after establishing the practical context does it introduce the general methods. That's sophisticated teaching. It meets learners where they are rather than demanding they immediately leap to abstraction. It shows why the methods matter before explaining how they work. It builds from concrete to abstract rather than imposing abstraction from above. Someone who writes like that has thought carefully about learning. They understand that motivation precedes comprehension, that context aids retention, that examples clarify principles. These pedagogical insights aren't just technical skills. They reflect a theory of mind, an understanding of how people actually think and learn. They suggest someone who paid attention to students, who noticed what worked and what didn't, who revised their approach based on feedback. None of this appears in biographical records, but it appears in the text itself, if you know how to look. This is what literary scholars call the implied author, the personality you can reconstruct from reading someone's work, distinct from both the real person and the explicit narrator. The implied author of Khwarizmi's algebra book is patient, systematic, practical-minded, and concerned with clarity above all else. Is that who Khwarizmi really was? Maybe, maybe not. But it's the personality embedded in the text, and that personality shaped how generations of readers understood mathematics. The real Khwarizmi could have been impatient, disorganized, impractical, and unclear in conversation. We don't know. But when he sat down to write, he became the patient teacher. And that's the version that mattered historically. This suggests a final thought about why biographical absence might not be as problematic as it first appears. The version of Khwarizmi that influenced mathematics wasn't the complete human being with all his quirks and contradictions. It was the distilled essence preserved in his books. That distilled essence is still available to us. We can read the algebra book and encounter the mind that organized it. We can study the arithmetic text and see how that mind approached teaching. We can examine the astronomical tables and observe the attention to precision and systematic method. These aren't complete portraits. They're partial glimpses, fragments of a larger whole we'll never fully reconstruct, but fragments can be valuable. A shard of pottery tells us something about ancient civilizations, even if we can't reconstruct the entire vessel. Khwarizmi's books are shards, pieces of a larger person and a larger historical moment. We can study the shards carefully, extract what information they contain, acknowledge the limits of what we can know. And maybe that's enough. Maybe the goal isn't to recover everything about every important historical figure. Maybe it's to understand their work, trace their influence, and appreciate their contributions while remaining honest about the gaps in our knowledge. Khwarizmi changed mathematics. His methods spread across civilizations. His name entered languages he never spoke. The person behind all that remains mostly mysterious, and that's frustrating but not fatal to historical understanding. We can know enough to appreciate his significance without knowing everything about his life. We can trace his influence without reconstructing his personality. We can study his legacy without writing his biography. This isn't ideal. Given the choice, historians would always prefer more information to less, but we work with what survives, not with what we wish had survived. What survives of Khwarizmi is substantial, even if incomplete. The books exist, the influence is documented, the mathematical methods continue functioning regardless of biographical gaps. And perhaps there's something appropriate about that. A man who valued practical utility over personal glory, whose books focused on methods rather than philosophy, whose work was meant to be used rather than admired. Maybe it's fitting that the work survived while the person faded. The algorithm doesn't need its inventor's biography to function. It just needs to work. And Khwarizmi's algorithms work. They've been working for over 1,000 years. They'll keep working whether we ever learn more about his life or not. That's not nothing. That's actually quite remarkable. To create something so useful that it outlasts everything else about you, that your name becomes permanently attached to a fundamental concept, even as your personal story disappears. The algorithm is immortal. The man is not. This seems like an unequal trade until you consider what most people leave behind. Most of us vanish completely. No trace, no influence, no name attached to anything that outlasts our immediate circle of family and friends. Khwarizmi created something that has now touched billions of people across 12 centuries. The personal details might be lost, but the impact remains massive and permanent. That's not a consolation prize. That's an extraordinary achievement. So maybe we should stop thinking about the biographical gaps as failures of the historical record and start thinking about them as evidence of what Khwarizmi himself valued. He didn't write autobiographies, he wrote textbooks, he didn't commission portraits or monuments, he organized knowledge, he chose utility over immortality, and ironically, achieved a different kind of immortality. As a result, the algebra book mattered more than the man who wrote it. That was probably fine with him. Now, we need to address something that makes the whole story more complicated. Everything we've discussed assumes the books attributed to Khwarizmi were actually written by someone named Muhammad ibn Musa al-Khwarizmi. But historical attribution in the Islamic medieval period is messy. Texts circulated, were copied, were modified, were sometimes attributed to the wrong authors. Entire books were sometimes credited to famous scholars simply because that made them sell better or seem more authoritative. Could the algebra book have been written by someone else entirely? Could Khwarizmi be a fictional attribution? Probably not. The evidence for Khwarizmi's historical existence is decent even if the biographical details are sparse. Multiple independent sources reference him. The dedication to Caliph al-Ma'mun in the algebra book connects to a specific time and place. The linguistic features of the text match the period and region. The mathematical content fits with what we know about the development of algebra in 9th century Baghdad. But here's the uncomfortable part. Even if Khwarizmi, the person, definitely existed and definitely wrote the books attributed to him, we can't be completely certain about which ideas originated with him versus which ones he compiled from earlier sources. The algebra book presents itself as a synthesis. Khwarizmi explicitly says he's gathering methods from different sources and organizing them systematically. He's not claiming to have invented algebra from scratch. He's claiming to have created a useful textbook that brings together scattered knowledge. This was standard practice in medieval Islamic scholarship. You earned prestige not by claiming total originality, but by creating the best synthesis, the clearest explanation, the most systematic organization of existing knowledge. Khwarizmi was working in a tradition where compilation and organization were valued skills, not lesser activities compared to pure innovation. But this makes historical attribution difficult. When we say Khwarizmi invented algebra, what exactly do we mean? Did he invent the methods themselves? Did he invent the systematic approach to teaching them? Did he invent the terminology? Did he simply document methods that already existed in oral tradition? The honest answer is we're not entirely sure. The algebra book is our earliest surviving systematic treatment of algebraic methods in Arabic. That doesn't necessarily mean earlier treatments didn't exist and simply didn't survive. Khwarizmi might have been building on texts we no longer have access to. There are hints of this in the text itself. Occasionally, Khwarizmi refers to methods that seem to be common knowledge, suggesting they weren't his inventions. Other times, he presents techniques in ways that suggest he's explaining something for the first time to an audience unfamiliar with these approaches. Sorting out which is which requires careful textual analysis and contextual knowledge about mathematical development in the Islamic world. Scholars have been doing this work for decades, and the consensus seems to be that Khwarizmi was genuinely innovative in his systematic organization, even if many individual techniques had earlier origins. But consensus isn't certainty. New manuscript discoveries could change our understanding. A text older than Khwarizmi's might surface that shows algebra was more developed before him than we currently realize, or evidence might emerge that some techniques we attribute to him actually came from his contemporaries. This uncertainty doesn't diminish Khwarizmi's importance. Even if every single algebraic technique in his book had earlier origins we haven't discovered, his achievement in organizing them into a coherent system would still be historically significant. Sometimes the person who organizes existing knowledge clearly makes a bigger impact than the scattered originators of individual pieces. Consider Darwin and evolution. Natural selection had been proposed by others before Darwin. The idea that species change over time wasn't original to him, but Darwin's systematic presentation in On the Origin of Species, his massive accumulation of evidence, his clear argumentation, That's what made evolution a scientific revolution, rather than a scattered collection of interesting ideas. Khwarizmi might occupy a similar position in mathematics, not the originator of every technique, but the systematizer who made those techniques accessible and transmissible to future generations. That's still a crucial role, still worthy of historical recognition. But it does mean we need to be careful about claims of invention. Saying Khwarizmi invented algebra is shorthand. The more accurate statement would be, Khwarizmi wrote the earliest surviving systematic Arabic treatment of algebraic methods, organizing and explaining techniques that transformed how mathematics was taught and practiced. Though the extent to which individual methods originated with him versus earlier mathematicians remains uncertain, that's less catchy, it's also more honest. The attribution problem extends beyond just the algebra book. The astronomical tables attributed to Khwarizmi definitely borrowed heavily from Indian and Persian sources. Khwarizmi explicitly acknowledged this. He was adapting and translating existing astronomical knowledge, not creating it from scratch. The arithmetic book teaching Hindu numerals was again a transmission, an explanation of methods that originated elsewhere. Khwarizmi deserves credit for clear explanation and systematic organization, but the numerals themselves and the basic calculation methods came from India. Even the practical applications, surveying, inheritance problems, commercial calculations, these weren't invented by Khwarizmi. They were established problems with existing solution methods. Khwarizmi's contribution was collecting them, organizing them, and explaining them clearly in Arabic. So what did Khwarizmi actually invent? Maybe nothing. Maybe everything depends on how you define invention. If invention means creating something from nothing with no predecessors, then probably Khwarizmi invented very little. If invention means taking existing elements and combining them in new ways that prove more useful than previous arrangements, then Khwarizmi invented quite a lot. Most innovation works this way. Genuinely novel creation ex nihilo is rare. Most creative work involves recombining, reorganizing, clarifying, systematizing, translating, adapting. These activities require skill and insight, even if they're not pure origination. Khwarizmi's genius might have been pedagogical rather than mathematical. His gift might have been understanding how to teach, how to organize knowledge so students could grasp it, how to structure material so it built logically from simple to complex. That's valuable, perhaps more valuable in the long run than a brilliant but incomprehensible original insight. A genius whose ideas die with them because nobody can understand or use them leaves less lasting impact than a skilled teacher whose clear explanations spread knowledge across continents and centuries. Khwarizmi was a teacher. His books were textbooks. Their purpose was transmission, not innovation, and they succeeded spectacularly at that purpose. This raises another question about historical recognition. Do we give too much credit to individuals when developments might be more collective than our narratives suggest? The story of Khwarizmi inventing algebra is clean and simple. It satisfies our desire for heroes and origin points, but the real story is probably messier. Algebra emerged from a complex network of mathematical developments across multiple cultures over many centuries. Indian mathematicians contributed, Persian scholars contributed, Greek geometrical thinking contributed, Babylonian problem-solving traditions probably contributed, Chinese mathematics might have contributed through intermediary connections we don't fully understand. All of this flowed into Baghdad during the Abbasid period. The House of Wisdom was collecting and translating mathematical texts from multiple traditions. Khwarizmi was one scholar among many working in this environment. His books captured a particular moment in that larger story. They happened to survive, happened to be clear enough to spread widely, happened to be in the right place at the right time to reach Europe, when Europe was ready to receive mathematical knowledge from the Islamic world. Luck played a role. Timing played a role. The specific needs of European scholars in the 12th century played a role in which texts got translated and which got ignored. If Khwarizmi's books hadn't survived, would someone else's work have played the same role? Possibly. The broader mathematical developments would have continued. Europe would have eventually encountered algebra through other routes. The specific terminology might be different. We might not say algorithm or algebra, but the underlying mathematical methods would have spread regardless. This is uncomfortable territory for historical narrative. We want individuals to matter. We want to believe specific people make irreplaceable contributions. And individuals do matter, just perhaps not quite as decisively as our stories suggest. Khwarizmi mattered. His specific choices about how to organize and present mathematical knowledge had real consequences. But he was also part of larger currents that would have flowed with or without him, perhaps just through different channels. Both things can be true simultaneously. Khwarizmi was important and Khwarizmi was replaceable. His work was influential, and his work was one expression of broader developments that had multiple potential expressions. Historical counterfactuals are tricky. We can't run controlled experiments where we remove Khwarizmi from history and see what happens. But we can note that mathematics developed in multiple places independently. Algebra emerged in India separately from Arabic developments. Chinese mathematics developed its own algebraic methods. The underlying logic of algebraic thinking seems to be something humans discover repeatedly when conditions are right. Khwarizmi's version happened to be the one that reached medieval Europe and shaped Western mathematics, but it wasn't the only version possible, or the only version that existed. It was one path among several that mathematical knowledge could have taken. This doesn't diminish Khwarizmi's achievement, it just contextualizes it. He was a skilled navigator of existing mathematical knowledge who created particularly useful maps for others to follow. Those maps proved valuable enough to be copied and transmitted for centuries. That's success, even if it's not solitary genius inventing everything from scratch. The mythology around Khwarizmi needs adjustment, not abandonment, just refinement. He remains historically important, but the nature of his importance is more nuanced than the simple inventor narrative suggests. He organized, he clarified, he taught, he synthesized, he wrote books that survived and spread. These are all valuable activities that deserve recognition. They're just different from the pure creative genius model we sometimes impose on historical figures. Perhaps the better question isn't whether Khwarizmi invented algebra, but why his book succeeded where others didn't. What made his algebra text the one that got translated into Latin? What made his name the one that became algorithm? Some of it was content quality. The books were genuinely well organized and clearly written. Some of it was timing. They appeared at a moment when there was demand for systematic mathematical texts. Some of it was institutional support. Being associated with the House of Wisdom and the Abbasid court gave the work prestige and circulation. And some of it was probably accident, the right manuscript reaching the right translator at the right moment in 12th century Spain. Historical influence often involves contingency as much as inevitability. The combination of these factors, quality, timing, institutional backing, fortunate transmission, created Khwarizmi's lasting impact. Remove any single element and the story might have unfolded differently. This is the messy reality behind the clean narrative. Khwarizmi matters, but he matters through a complex web of circumstances, not just through individual genius. His achievement was real, but also dependent on context, support, timing, and luck. Understanding this doesn't diminish the achievement, it makes it more interesting. Pure, isolated genius is actually less fascinating than genius working within specific historical conditions, responding to particular needs, building on available resources, and succeeding partly through skill and partly through circumstances aligning favourably. That's the version of Khwarizmi worth understanding. Not a mythological inventor pulling algebra from thin air, but a skilled scholar working in a productive environment, creating useful syntheses of existing knowledge and benefiting from favourable conditions that allowed his work to spread and endure. Human but historically consequential, part of larger currents but still individually significant. Neither myth nor accident, but something more complex and more real. The larger point extends beyond Khwarizmi himself. We do this with many historical figures. We compress complex processes into single names. Edison invented the light bulb. Bell invented the telephone. Ford invented mass production. Each statement is true enough for casual conversation, but false in the details that actually matter. Edison developed one commercially successful version of the light bulb after decades of work by multiple inventors. Bell won a patent race that several others were running simultaneously. Ford systematized assembly line techniques that others had pioneered. These men deserve credit for what they actually did, not for simplified myths that erase everyone else involved. The same pattern applies to Khwarizmi. He wrote important books on algebra and arithmetic. Those books influenced centuries of mathematical development. His name gave us the word algorithm. These are real contributions worth acknowledging. But he didn't invent algebra from nothing, and he wasn't working in isolation from prior mathematical traditions. This matters for how we understand intellectual history. Progress doesn't happen through isolated geniuses having sudden breakthroughs. It happens through communities of scholars building on each other's work, institutions providing resources and support, translations making knowledge cross linguistic boundaries, and countless unnamed contributors whose work gets absorbed into the tradition without individual credit. Khwarizmi benefited from all of this. Indian mathematicians developed key concepts. Greek geometers created analytical frameworks. Persian scholars translated and commented on earlier texts. The Abbasid Caliphate funded scholarly work. Fellow scholars at the House of Wisdom provided intellectual community. Later translators carried his work to Europe. Every step involved multiple people making the transmission possible. Recognizing this doesn't diminish Khwarizmi. It just places him accurately within the actual process of how mathematical knowledge develops and spreads. He was a crucial link in a long chain, not the chain's origin point. That's still an important role. We need synthesizers and systematizers, not just original innovators. Someone has to organize scattered knowledge into coherent systems that others can learn from and build upon. Khwarizmi excelled at that role. His algebra text took various solution methods for specific equation types and presented them systematically. His arithmetic book explained Hindu numerals and decimal calculation in ways that made sense to Arabic readers. These weren't trivial accomplishments. Making knowledge accessible is its own form of creation. But accessibility and organization are different from invention. A good textbook author creates value without necessarily creating new knowledge. Khwarizmi was, in some sense, writing textbooks. Very good textbooks that proved influential for centuries. That's an achievement, just not the achievement the mythology assigns to him. The mythology serves purposes beyond historical accuracy. It provides simple narratives for education. It creates heroes for different cultures to claim. It gives names to complex processes that are hard to explain without personification. These purposes aren't necessarily bad, but they do conflict with understanding what actually happened. For educational purposes, saying Khwarizmi invented algebra is efficient. It gives students a name to remember, a point of origin for the subject they're learning. The full story involving Indian mathematicians, Greek geometry, Babylonian equation solving, and Arabic synthesis is too complex for introductory classes. Simplification makes pedagogical sense. For cultural purposes, Khwarizmi represents Islamic contributions to mathematics during Europe's medieval period. That contribution was real and significant. The Islamic world preserved and extended classical knowledge while Europe struggled through political fragmentation. Highlighting Khwarizmi acknowledges that historical reality, the fact that his specific role was synthesis rather than invention, doesn't diminish the broader point. These purposes explain why the mythology persists despite historical complications. It serves needs beyond accurate representation of 9th century mathematics. But those needs shouldn't prevent us from understanding the actual history when we take time to examine it carefully. The examination reveals a more interesting story than the mythology suggests. Instead of lone genius, we see knowledge moving across cultures and languages. Instead of sudden invention, we see gradual development building on multiple traditions. Instead of individual achievement, we see collaborative scholarly communities making progress collectively. This version is richer and more instructive. It shows how intellectual progress actually works. It reveals the importance of institutions like the House of Wisdom that create conditions for scholarship. It demonstrates the value of translation in making knowledge accessible across linguistic boundaries. It highlights how synthesis and systematization contribute to mathematical development alongside innovation. It also makes Khwarizmi more human. The mythological inventor is distant and untouchable. The historical scholar working within specific circumstances and limitations is someone we can understand. He faced challenges we recognize. He worked with available resources. He made choices about what to include and how to organize material. He succeeded partly through skill and partly through favorable conditions. That's more relatable than supernatural genius. The human version is also more useful for understanding how we might support intellectual progress today. If progress requires lone geniuses, there's little we can do except hope they appear. If progress requires supportive institutions, collaborative communities, translation and synthesis of existing knowledge, and favorable conditions for scholarly work, then we can actually create those conditions. The Abbasid Caliphate understood this at some level. They funded scholarly institutions. They supported translation projects. They created an environment where scholars from different backgrounds could work together. The result was several centuries of significant intellectual achievement, not because they had more geniuses than other places, but because they created conditions where scholarship could flourish. Modern research universities attempt something similar. They provide resources, bring diverse scholars together, support time for deep work, and facilitate collaboration. The specific mechanisms differ from 9th century Baghdad, but the underlying principle remains. Intellectual progress needs more than individual brilliance. It needs infrastructure, community, and support. Khwarizmi thrived in such an environment. His work was possible because the conditions were right. This doesn't minimize his contribution, but it does suggest that similar contributions require similar conditions. If we want more Khwarizmis, we need more institutions like the House of Wisdom. Not identical institutions, obviously, but ones serving similar functions for their time and place. This perspective shifts how we think about intellectual history. Instead of focusing solely on great individuals, we examine the systems that enabled them. Instead of asking what made Khwarizmi special, we ask what made 9th century Baghdad conducive to mathematical scholarship. The answers are probably more useful for present purposes than biographical details about any single scholar. The shift also affects how we tell these stories. The traditional narrative is simpler and more dramatic. Khwarizmi invents algebra. It's a clear, memorable claim. The nuanced version is messier. Khwarizmi synthesized various mathematical traditions into systematic texts that proved influential. It's accurate but less punchy. Perhaps we need both versions. The simple one for initial introduction, the complex one for deeper understanding. Tell students about Khwarizmi inventing algebra when introducing the subject. Later, when they're ready for historical nuance, explain the fuller context. Different purposes require different levels of detail. The danger is getting stuck in the simple version. Many people never move beyond the initial simplified narrative. They carry the mythology forward without ever encountering the complications. This produces distorted understanding of how intellectual progress actually works. It perpetuates the lone genius myth that doesn't match historical reality. Breaking that myth matters, not because Khwarizmi doesn't deserve recognition, but because the myth obscures what actually produces intellectual advancement. When we attribute everything to individual genius, we ignore the conditions that make genius productive. When we focus solely on singular achievements, we miss the collaborative processes that enable them. The goal isn't to deflate historical figures, but to understand them accurately. Khwarizmi was important, just not in exactly the way popular accounts suggest. His importance lay in synthesis and systematization rather than pure invention. That's still valuable. We need good synthesizers. Mathematical knowledge doesn't organize itself into coherent systems without effort. Khwarizmi provided that effort. He took scattered methods and presented them systematically. He explained decimal arithmetic clearly enough that later scholars could learn and transmit it. He wrote books that survived and influenced mathematical development for centuries. These accomplishments stand regardless of whether we call them invention or synthesis. The terminology matters less than the understanding. Whether we say he invented algebra or synthesized it, we should recognize what he actually did and the context that made it possible. We should acknowledge the prior traditions he built on and the institutional support that enabled his work. We should understand his achievement as part of a larger process, not an isolated event. This understanding doesn't diminish Khwarizmi. If anything, it makes his achievement more impressive. Working within constraints, building on existing knowledge, creating something useful from available materials, these require skill and judgment. Synthesis isn't lesser than invention. It's just different, and sometimes equally important. Mathematical progress needs both innovation and organization. New ideas matter, but so does making existing ideas accessible and systematic. Khwarizmi excelled at the latter. His books helped transmit mathematical knowledge across time and space. That contribution shaped how mathematics developed in Europe and beyond. The transmission process itself deserves attention. Khwarizmi's algebra text was translated into Latin in 12th century Spain. The translation wasn't straightforward. Arabic mathematical terminology didn't map cleanly onto Latin. Translators had to make choices about how to render concepts. Different translations made different choices, creating variations in how the content was understood. Some translations preserved technical terms from Arabic, giving us words like algebra itself. Others tried to translate everything into Latin, creating new terminology. Still others mixed approaches. Each choice affected how European mathematicians understood and built on the work. This translation process was as important as the original composition. Without translation, Khwarizmi's books would have remained accessible only to Arabic readers. The knowledge would have stayed confined to the Islamic world. Translation made transmission possible, allowing the mathematical methods to influence European development. But translation also transformed the content. It wasn't neutral transmission. Translators interpreted, adapted, and sometimes misunderstood. The version of Khwarizmi that reached medieval Europe wasn't identical to the Arabic original. It was a translation-mediated version, shaped by translators' choices and limitations. This matters for understanding influence. When we say Khwarizmi influenced European mathematics, we're really saying his translated texts influenced European mathematics. The influence was real, but mediated. European mathematicians learned from a version of Khwarizmi filtered through translation. That's still influence, just not direct influence from original to recipient. The same pattern appears throughout intellectual history, Ideas cross cultural and linguistic boundaries through translation. Translation always involves interpretation and transformation. The ideas that arrive aren't identical to the ideas that departed. They're adapted versions, changed by the transmission process. Recognizing this complicates simple narratives of influence. It's not just that Khwarizmi influenced Europe, it's that particular translations of Khwarizmi, made at particular times by particular translators, influenced particular European mathematicians who interpreted the translated texts in particular ways. The chain of transmission involves multiple steps, each adding variation. This doesn't make the influence unreal, it makes it complex. Khwarizmi's work reached Europe and shaped mathematical development there. That happened through a specific process involving translation, transmission, and interpretation. Understanding the process helps us understand the influence more accurately. The same applies to Khwarizmi's relationship with earlier sources. He didn't directly access Indian mathematics or Greek geometry. He learned from Arabic translations and commentaries. Those translations shaped how he understood the material. His synthesis was built on already mediated sources. We're looking at layers of transmission and interpretation. Indian mathematicians developed concepts. Those concepts were translated into Arabic. Arabic scholars commented on them. Khwarizmi studied the translations and commentaries. He synthesized what he learned into new texts. Those texts were later translated into Latin. European mathematicians studied the Latin versions. Each step involved transformation. This is how intellectual traditions actually work. Not as pure transmission of unchanging ideas, but as complex processes of translation, interpretation, synthesis, and adaptation. Ideas change as they move. Sometimes they improve, becoming clearer or more general. Sometimes they lose nuance or pick up errors. Usually both happen simultaneously. Khwarizmi was positioned within this process. He received transformed versions of earlier knowledge. He created new syntheses that were themselves transformed by later transmission. His role was important, but not unique in kind. He did what many scholars do: worked with available sources, organized them effectively, and passed them forward in new form. The result was historically consequential. His books influenced how mathematics developed across multiple centuries and cultures. That's real achievement. It just happened through messy historical processes rather than clean mythological narratives. The messiness doesn't reduce the importance. It just makes the story more complicated and more interesting. Understanding this process also changes how we evaluate Khwarizmi's originality. The concept of originality itself is historically specific. Modern academic culture prizes creating entirely new ideas. Medieval scholarship valued something different: authoritative synthesis and clear transmission. Khwarizmi excelled at what his culture valued. He gathered scattered knowledge, organized it systematically, and presented it accessibly. That was considered important scholarly work. It still is important, just differently valued than in his time. Claiming Khwarizmi invented algebra from nothing would be false. Claiming he merely copied earlier sources would also be false. He did something between those extremes. He worked with existing materials and created something genuinely useful that hadn't existed before. The books weren't identical to their sources. They were new compositions that served new purposes. This middle position is harder to celebrate than either extreme. We like stories of lone genius creating from nothing. We also like stories of fraud exposed, showing celebrated figures were just copyists. Reality offers neither satisfaction. Khwarizmi was neither pure genius nor mere compiler. He was a skilled scholar who made important contributions within historical constraints. Those contributions matter precisely because they weren't isolated achievements. They fit into larger patterns of knowledge transmission. Mathematics develops through many people working across time. Each person adds something, however small. The additions accumulate. Eventually, You have a rich, complex tradition that no single person created but many people built. Khwarizmi's additions were larger than most. His books became reference points. They shaped how later scholars approached mathematics. That's significant influence. It happened because he wrote clearly, organized effectively, and positioned himself well within scholarly networks. Those aren't dramatic virtues, but they're real ones. The legacy question also involves how later generations used his work. Khwarizmi didn't control what happened to his books after he died. Later scholars interpreted them in their own contexts, for their own purposes. The Latin translations served medieval European needs that Khwarizmi couldn't have anticipated. His name got attached to concepts he might not recognize. Algorithm comes from corrupted versions of his name. The word now means something different than what Khwarizmi taught. Modern algorithms involve computers executing precise instruction sequences. Khwarizmi's arithmetic procedures were pen and paper methods. Calling both algorithm stretches the term across very different technologies and contexts. Yet the etymological connection isn't arbitrary. Modern algorithms do descend historically from the kind of systematic procedures Khwarizmi explained. There's continuity even through the transformation. The word's meaning expanded as the techniques evolved. That expansion reflects genuine intellectual inheritance, not just accidental naming. Similar evolution happened with algebra. Khwarizmi's al-Jabr meant specific operations on equations. Modern algebra is far more abstract and general. It includes structures Khwarizmi never imagined. But the path from his work to modern algebra is traceable. Later mathematicians built on foundations he helped establish. This creates complex questions about credit and legacy. How much credit does Khwarizmi deserve for modern algebra if modern algebra is so different from what he did? How much does the Indian origin matter if European mathematics developed from Arabic transmission rather than direct Indian contact? These questions don't have simple answers. They require thinking about how intellectual traditions work. Ideas develop through networks of people over long time periods. Early contributors enable later developments they couldn't predict. Later developments transform what earlier contributors meant. Khwarizmi was an important early contributor to mathematical traditions that eventually produced modern mathematics. That's true, even though modern mathematics far exceeds what he knew. His importance doesn't require him to have invented everything or predicted everything. It just requires that his work mattered historically. It did. What would have happened without Khwarizmi? Would European mathematics have developed similarly? These counterfactual questions are impossible to answer definitively. We can't rerun history without Khwarizmi and see what happens. We only have the actual history where he existed and his books circulated. In that actual history, his books mattered. They were translated, studied, and referenced. They influenced how mathematics was taught and practiced. Would other books have served the same role if Khwarizmi hadn't written his? Maybe, but they didn't, because his books already existed and did the job effectively. This suggests his contribution was somewhat contingent. Someone else might have written similar books around the same time. The historical need for systematic mathematical texts was real. Multiple scholars could have filled it. Khwarizmi happened to do so successfully. But contingency doesn't mean unimportance. Many important historical developments were contingent. They happened through particular people in particular circumstances, but they still mattered. The circumstances that produced Khwarizmi's books were specific to Baghdad's scholarly environment in the early 800s. Different circumstances might have produced different books. The books that actually emerged shaped actual historical developments. Thinking about Khwarizmi this way avoids both excessive celebration and excessive deflation. He wasn't a superhuman genius who created mathematics from pure insight. He was a skilled scholar who worked effectively within his context. That context included access to earlier sources, support from the Abbasid court, and participation in scholarly networks. His success depended on those factors, yet he still had to do the actual work. He had to read the sources, understand them, organize them, and write clear explanations. That required skill and effort. Not everyone with the same access would have produced equally effective books. Khwarizmi's personal abilities mattered even though circumstances also mattered. The same balanced view applies to his relationship with Indian mathematics. Indian scholars developed crucial concepts, including the decimal system and algebraic methods. That was foundational work deserving recognition. But recognition of Indian contributions doesn't erase Khwarizmi's contribution. He wasn't just a passive transmitter. He actively synthesized and reorganized the material. Both the Indian originators and the Arabic synthesizer made important contributions. They were different kinds of contributions serving different functions in knowledge development. We can recognize both without diminishing either. This is where the mythology becomes problematic. Myths that present Khwarizmi as the solitary inventor erase Indian contributions and misrepresent how mathematics actually develops. But myths that reduce Khwarizmi to a mere copyist misrepresent his actual historical role. Neither myth serves understanding. Better understanding comes from accepting complexity. Multiple people contributed to developing algebra. They contributed different things at different times. Some developed core concepts. Others organized and transmitted those concepts. Still others extended and transformed them further. All these contributions mattered. Khwarizmi sits in the middle of this process. He received from earlier contributors and passed forward to later ones. His specific contribution was effective synthesis and clear exposition during a crucial period of knowledge transmission. That's historically significant, even though it's less dramatic than myths of solitary genius. The measurement question remains difficult. How do we quantify intellectual influence? How much weight should we assign to development versus transmission versus transformation? These aren't just academic questions. They affect how we tell history and whom we celebrate. Current scholarly consensus tries to balance multiple factors. Khwarizmi is recognized as important for algebra's history while acknowledging earlier sources. Indian mathematicians receive credit for foundational concepts. Greek contributions to geometry are noted. Later European developers are recognized. Everyone gets acknowledged for their specific contributions. This balanced approach is more accurate than single hero narratives. It better reflects how knowledge actually develops through collective effort over time. But it's also less satisfying narratively. We like clear heroes and dramatic breakthroughs. Distributed credit across many people over centuries doesn't make compelling stories. Yet accuracy matters more than narrative satisfaction. If we want to understand mathematics' actual history, we need to accept that history's complexity. That means accepting Khwarizmi as important but not uniquely responsible. It means recognizing multiple contributors across multiple cultures. It means understanding transmission as active process rather than passive copying. Does this diminish Khwarizmi? Not if we value accurate understanding over mythological celebration. His real contributions were substantial. He wrote influential books that shaped mathematical practice for centuries. Those books synthesized earlier knowledge effectively and transmitted it successfully. That's genuine achievement worth recognizing. What we lose is the myth of the lone genius creating from nothing. What we gain is understanding of how intellectual traditions actually work. That trade seems worthwhile. Myths are comfortable but misleading. Reality is messy but informative. The broader lesson extends beyond Khwarizmi to how we think about intellectual history generally. Most major developments involve multiple contributors. Most celebrated figures built on earlier work. Most inventions were really syntheses or reorganizations of existing ideas. Recognizing this doesn't devalue anyone's contributions. It just locates those contributions accurately within larger processes. Khwarizmi becomes more interesting, not less, when we understand him this way. Instead of an inexplicable genius, we see a skilled scholar operating within specific historical circumstances. We can understand how he succeeded by understanding those circumstances. That's more informative than treating him as mysteriously gifted. It also makes his achievements seem more replicable. If success came partly from circumstances and skill rather than purely from innate genius, then others can learn from his example. Clear organization, effective synthesis, and good positioning within scholarly networks are skills that can be developed. That's more useful than believing success requires unrepeatable genius. So the final assessment of Khwarizmi's legacy is complex but clear. He made significant contributions to mathematics through effective synthesis and transmission. Those contributions built on earlier work and enabled later work. His books influenced mathematical practice across multiple centuries and cultures. That influence came through specific historical processes involving translation, interpretation, and adaptation. He wasn't the father of algebra, if that means sole creator. He was an important contributor to algebra's development through his role in organizing and transmitting knowledge during a crucial period. That's real achievement deserving recognition. It just needs to be recognized accurately rather than mythologically. The man who lived in Baghdad 12 centuries ago and wrote books about arithmetic and algebra couldn't have known his work would echo through so many later centuries. He couldn't have predicted that his name would become an English word or that scholars would still study his texts. He was working within his immediate context, addressing contemporary needs. Yet his work transcended that context because it addressed fundamental problems in clear, systematic ways. The problems of solving equations and performing calculations remained relevant long after his time. His solutions, while not final, provided tools others could build on. That's why his books kept being copied, translated, and studied. The transmission process that carried his work forward also transformed it. The Khwarizmi that influenced medieval Europe was mediated through translation. The algebra that developed in later centuries went far beyond what he knew. His legacy isn't a simple line of direct influence, but a complex web of transformations and adaptations. Understanding that complexity doesn't diminish his importance, it shows how intellectual traditions really work, through many people contributing and transforming over long periods. Khwarizmi was one important node in that network. His position and contributions mattered. The network continued developing far beyond him. That's perhaps the most important lesson. No single person determines how knowledge develops. Everyone works within traditions they inherited and contributes to traditions that continue after them. Khwarizmi did this particularly effectively. That's why we still discuss him 1200 years later, trying to understand exactly what he contributed and how it mattered. The question that opened this exploration was what Khwarizmi actually did and how much credit he deserves. The answer is nuanced but clear. He wrote important books synthesizing mathematical knowledge during a crucial period of cultural transmission. Those books influenced how mathematics developed across multiple centuries. His contribution was real and significant, though built on earlier work and transformed by later developments. That's the actual story. Complicated, but historically grounded. It's a story about how human knowledge grows through collective effort across time, with some contributors, like Khwarizmi, playing particularly important roles in that ongoing process. When you opened your phone this morning, typed a password, checked the time, maybe calculated a tip at lunch, you were using systems refined by countless hands across centuries. The decimal numbers came from India. The systematic procedures came through Arabic scholars. The transmission to Europe happened through medieval translators. And somewhere in that chain, a man in 9th century Baghdad wrote books that helped carry these ideas forward. Not the origin, not the end point. Just one particularly effective link. That's what makes the story worth understanding. Not because Khwarizmi was superhuman, but because he was human. He worked with what he had. He organized knowledge that already existed. He wrote clearly enough that others could learn and transmit further. These aren't mythological achievements, they're practical ones, and they mattered. The name algorithm will outlast almost everything else from his era. The Abbasid Caliphate collapsed. The House of Wisdom was destroyed. The specific problems he solved are obsolete, but the idea that you can break complex procedures into systematic steps, that you can teach methods through clear organization, that knowledge becomes more powerful when it's accessible. These ideas persist because they work. Every textbook that explains a concept step by step is doing what Khwarizmi did. Every teacher who breaks down complexity into learnable parts is following his approach. Every translation that makes knowledge cross linguistic boundaries is continuing the work that carried his books from Baghdad to Europe and beyond. The personal details are gone. We'll never know what he thought about his work, or how he spent his evenings, or what he hoped his legacy would be. But we have what matters more: the evidence of what he actually accomplished. Books that survived, methods that spread, influence that shaped mathematics for centuries. That influence wasn't clean or direct. It moved through translations that transformed it, through interpretations that changed it, through generations of scholars who built on it and moved beyond it. The algebra Khwarizmi knew became something different. The algorithms expanded far past what he imagined. His contributions were starting points that others carried forward in directions he couldn't have predicted. This is how human knowledge actually develops, not through isolated geniuses creating from nothing, but through networks of people building on each other's work across time. Some contributions are larger than others. Khwarizmi's were substantial. He wasn't unique in kind, just unusually effective at synthesis and transmission. That was enough to matter for 12 centuries and counting. The mythology will probably persist. It's cleaner to say he invented algebra than to explain the complex reality. Educational needs and cultural pride will keep the simplified version alive. That's fine for introductory purposes, but when you want to understand how knowledge actually moves through history, how ideas cross cultures and transform through transmission, how individual contributions fit within collective processes, then you need the complicated version. The complicated version is more interesting anyway. It shows mathematics as a human enterprise, built slowly by many hands. It reveals the importance of institutions like the House of Wisdom that create conditions for scholarship. It demonstrates how translation and synthesis matter alongside innovation. It makes intellectual progress seem less mysterious and more replicable. If supporting scholarship, facilitating translation, organizing knowledge clearly, and creating collaborative environments can produce results like Khwarizmi's, then we know what to do. We don't need to wait for unpredictable genius. We can build structures that help capable people contribute effectively. That's a more useful lesson than believing everything depends on irreplaceable individuals. Khwarizmi worked within a system that supported scholarly work. He accessed multiple intellectual traditions through translations. He had time and resources to synthesize what he learned. He wrote for audiences who needed practical mathematical tools. All those factors mattered. His skill mattered too, but skill alone wouldn't have been enough without favorable conditions. The same pattern appears throughout intellectual history. Major developments happen when circumstances align, when knowledge converges from multiple sources, when institutions provide support, when needs create demand for new syntheses, when skilled people are positioned to take advantage of these opportunities. Khwarizmi benefited from all of this. So did many others whose names we know, and many more whose names we've forgotten. What remains, centuries later, is what they built together. A mathematical tradition that developed through Indian innovations, Greek geometry, Babylonian techniques, Arabic synthesis, and European extensions. Each culture added something. Each contributor mattered. The tradition became richer and more powerful through this accumulation. You're part of that tradition now. Every time you solve an equation or follow an algorithm, you're using tools refined through that long collective process. The methods feel natural because you learned them young, but they're actually historical artifacts, products of specific human choices and efforts. Someone had to figure out each step. Someone had to organize the knowledge. Someone had to pass it forward. Khwarizmi was one of those someones. He did his part effectively enough that we still discuss him 1200 years later. Not because he was perfect or solitary or mythologically gifted, because he was skilled, well-positioned, and lucky enough to have his work survive and spread. That combination of factors produced lasting influence. The influence continues transforming. Modern computers execute algorithms that would baffle Khwarizmi. Contemporary algebra bears little resemblance to his equation-solving techniques. Yet the connections are real. The intellectual lineage runs from his books through medieval translations to modern mathematics, changed at every step, but never entirely severed. That's legacy enough. Not creating everything, but contributing effectively to traditions that outlasted him. Not working alone, but collaborating across time with people he never met. Not achieving perfection, but doing good enough work that others could build on it. The algorithm keeps running. The tradition keeps developing. And somewhere in the chain of transmission that brought mathematics to where it is today, a scholar in 9th century Baghdad organized some knowledge clearly and passed it forward. That was sufficient. That was what was needed. That's why we remember him at all.